notes. So as I was just saying here, I'm going to highlight though, most of this section is review, some SOHCAHTOA, using some trig functions, thinking about where trig functions are positive and negative, proving on some identities, some factoring, lots of different stuff. This is why I said indirectly it does help prepare you for the semester exam. But there is one question type in here that does not match up with anything else we've done, and this is called trig substitution. So let me go over question 1 with you, and then I will pause and let you try question 2 before we go over that one. Okay, so question 1 says, use trig substitution to write the algebraic expression as a trigonometric function of theta, where theta is in quadrant 1. Use that x is 5 times the tangent of theta. Okay, so usually the step that people do a good job with is they say, okay, if this is x, I will substitute that in. So instead of x squared, you've got 5 tangent squared. And then typically people say, okay, 5 tangent times 5 tangent is 25 tangent squared. And then here's where the big mistake happens. So I'm going to write out the wrong thing and then put a line through it. I know it's tempting to say, well, I could just square root 25 tangent squared to get 5 tangent. And then I could square root 25 to get 5. But that's not how square roots work. So I probably have shown you this example earlier this year, but if you use a couple numbers here, you can't just take the square root of 9 and then take the square root of 16 and add them. You're going to think the answer is 7 when the answer is actually 5. Okay, so you can't square root the terms like this, only if they're factors, only if they're being multiplied. So instead, what you need to do, and I would recommend that you put that on your notes and put a line through it. Instead, what you can do is you can say, well, both of these have a 25, so let me factor that GCF out. And then finally, we can make a replacement right here. Now, I know we haven't had to use these too much lately, but our Pythagorean identities are certainly one of the more important things from this semester. So sine squared plus cosine squared equals 1 should be the only one you have to memorize. Divide everything by sine squared to get the next one, or divide everything by cosine squared to get the third one. And so instead of saying tangent squared plus 1, we can put in a secant squared there. And now I can take the square root of the parts, because these are not terms now. They're not being added or subtracted together. The thing times itself that gives you 25 secant squared would be 5 secant. That's the one and only correct answer. So it's called trig substitution because we start by substituting this in. You can square what you plug in, but then do not square root the terms. You need to use one of these identities. Probably should write these at the top of your page. And then once you've got it in factors, things being multiplied, then you can do them separately. Okay, so finish copying that one down for notes. And then number 2 should be a very similar process, but I would like you to try it before I go over it, please. that long enough? Okay. So trig substitution, because you substitute this in. So instead of x squared plus 64, you've got 8 cotangents being squared plus 64. So then you can square root those, or square this. 8 cotangent times 8 cotangent would be 64 cotangent squared. And then, as much as I say this, it's still tempting to take the square root of the terms, but that's not how square roots work. Instead, you should have factored out the 64, like so. Said, wait, this is an identity, so instead of saying cotangent squared plus 1, cotangent squared plus 1 is cosecant squared. And now that these are not terms, they're not being added or subtracted, you can just take the square root of each piece. 8 times cosecant theta, 8 cosecant theta times 8 cosecant theta is 64 cosecant squared. So that's what you were aiming for. Okay with that? It's not that it's like a difficult arithmetic or anything, but you know, I'm trying to emphasize it as much as I can, because that is, as much as I emphasize it every year, and it's still a very common problem when we get to the quiz. So make sure you highlight what you should not do, so that makes that easy to review.